All right, so it's asks us to balance each of these reactions and then identify the type of reaction it is. So let's balance these first. Drop a wall, list my elements, Na, Br, Ca, O, and H. Gonna make sure I do them in the same order on both sides. And then do my count. On my reactant side, sodium I have 1, bromine I have 1, calcium I have 1. Oxygen is 1 inside the parentheses times the 2 outside the parentheses, which gives me a total of 2. And the same for my for my hydrogen. For my product side, sodium I have 1, bromine I have 2, calcium I have 1, oxygen I have 1, and hydrogen I have 1. So I'm going to look at it. Is it balanced? And it's not. I got a couple different things that I can start to look at to fix. My bromines, my calciums, and my hydrogens. I think I want to start on my reactant side. I'm going to start with my bromine and try to get that to even out. So that's going to need a 2 here. That changes my sodium to a 2 and my bromine to a 2. So now my bromines are balanced. But my oxygens and my hydrogens and my sodium aren't, which luckily they're all in the same molecule here on my my product side. Put a 2 coefficient here. That changes my sodiums, my oxygens, and my hydrogens. So I have 2, 1, 1, 2 for my balance on that one. I'm going to just keep going and do all the balancing first, and then we'll go through and we'll talk about what type of reaction they each are. For number 2, I'm going to drop a wall, do my count, nitrogen, hydrogen, sulfur, and oxygen, nitrogen, hydrogen, sulfur, and oxygen. Nitrogens, I have 1. For my hydrogens, I have 3 here and 2 here. So let's do 3 plus 2 gives me 5 total. Sulfur is 1 and oxygen is 4. On my product side, my nitrogen is a 1 inside the parentheses times 2 outside the parentheses is 2. Hydrogen is 4 inside times 2 outside, so that could be 8. Sulfur is 1 and oxygen is 4. So my hydrogens are weird. I don't want to mess with them if they don't have to. So let's start with my nitrogens first. I'm going to put a 2 here to double those nitrogens. That's also going to double my yellow hydrogens that I have here. So now those are 6 plus 2 is going to give me 8 altogether. And now my hydrogens are balanced. My nitrogens are balanced, my sulfurs are balanced, and my oxygens are balanced. So that one is all set. I'm going to come right out and say it. I tried working on number 3 with people in class today, and it is mean and scary. If you are having trouble balancing that one, do not stress yourself out. We're going to skip it for now. Number 4, we're going to drop the line. Have lead, hydrogen, phosphorus, and oxygen. Lead, hydrogen, phosphorus, and oxygen. All right, I have 1, 3, 1, and 1. 3, 2, 1 inside times 2 outside is 2, and 4 inside times 2 outside is 8. All right, so nothing's balanced. Why don't we... let's start with our phosphorus. I have 2 on the right, so I need to double my 1 on the left. That's going to make that a 2. That's going to make my hydrogen is going to double into a 6, and my oxygen, which my oxygen should be a 4, not a 1. Sorry about that. My oxygen is going to double to an 8. So I fixed my phosphorus and my oxygen. My hydrogens are out of whack now, so I have 6 on the left and 2 on the right, so I need a 3 coefficient here. That makes that into a 6, and then on the right I have 3 leads, on the left I have 1, so I need a 3 coefficient there, and that balances that out. All right, I'm gonna be honest, I've tried balancing number 5 3 different times and I've restarted the video and I just can't get it to work. So instead of putting up something that's not going to be correct, I'm gonna skip that one and we can talk about it in class if we need to. Let's look at 6. I have hydrogen, bromine, aluminum, oxygen, and hydrogen. Oh, I already have hydrogen. So I have, we'll come back to hydrogen in a second. Bromine, I have 1. Aluminum, I have 1. Oxygen, I have 1 inside times 3 outside is 3. For my hydrogens, I have 1 here and I have 1 there. So my yellow hydrogen is 1. Oops, let's do that in yellow though. My red hydrogens, I have 1 inside times 3 outside, so that is 3. So my hydrogen total count is 4. On the right side, hydrogen, bromine, aluminum, and oxygen. I have 2 hydrogens, 3 bromines, 1 aluminum, and 1 oxygen. So if I look at my count, my bromines and my oxygens are wrong. My hydrogen's wrong, but that's weird, so I'm going to come back to it later. So let's start with my bromines. On the left, I have 1. On my right, I have 3. So a 3 coefficient here is going to fix that. It's also going to change this yellow one to a 3 plus 3 is going to give me a 6 count for total now. So now my bromines are good. My hydrogens are still weird. My oxygens aren't good. So oxygens on the left, I have 3. On the right, I have 1. So I need to do a 3 coefficient here. That changes my oxygens. That's also going to change my hydrogen there to a 6, which balances out my hydrogens that I had going in the first place. So that one is all set. All right, so now we're going to go back and look at these all again, and we're going to identify what type of reactions we have. I'm going to, you know how much I like to color code. I'm going to color code these for that as well. So let me just erase some of my color codings that I have going on here so that we don't get mixed up. All right, so figuring out what type of chemical reaction you have is looking for patterns essentially. So I think it's helpful to kind of color code the things that go together. So I have a sodium here and a sodium here. I have a bromine here and a bromine here. I have a calcium here and a calcium here. And I have a hydrogen and oxygen bonded there and there. So if I look at this one now, I can see that I have 2 pairs that kind of swap places and everything ends up in pairs still, but they're in different pairs. So that is a double displacement or a double replacement depending on how old the book is that you're using. Either term is okay for us in class. So that is number 1. Number 2, I have, let's see, I have a nitrogen and a hydrogen and some more hydrogens and an SO4. Oh, well, I went and started color coding that, but if I look at it, it's not going to really be that complicated. I got 2 things, and really, if you look at it here, they're all turning into one big compound. So if I have 2 things joining together to become one thing, that is synthesis. All right, number 3, if I want to start looking at this one, I'm going to notice right away that I end up with carbon dioxide and hydrogen, and I have a hydrocarbon plus an oxygen, and that is the telltale sign of combustion. Number 4, I have, let's see, I have 1 thing here, and then I have 2 things here, and my hydrogen, we made that blue, my lead, we said was pink, my PO4 was green. So this looks like Mr. Steal Your Girl. I have 1 single thing and then 2 things, and I end up with 1 single thing and 2 things where the 1 thing that's on its own got kicked out and replaced. So that is single replacement or single displacement. All right, right, last but not, oh no, not last. I'm getting ahead of myself. Number 5. I have some lithium here and a lithium here. I got a nitrogen here and a nitrogen here. I got, let's see, an NH4 here, an NH4 there, and an NO3 there, and an NO3 there. So I got 2 complicated things turning into 2 other complicated things where they swap partners. That is double displacement. And number 6. I have a hydrogen here and a hydrogen here, a bromine here and a bromine here, an aluminum here and an aluminum here, and an OH here. Oh, I already used that color. An OH, there we go, OH there, and an O and an H in here. I have 2 complicated things turning into 2 other complicated things where something is getting swapped out, and that is double displacement again. All right, so we're going to go down here to the next bunch that we did not have to balance. We're just going to look at and sort them out. A lot of times I can look at it in like number 7, I can say, holy cow, that's a lot of complicated stuff. I don't even need to color code it. I can see that I have an Na here and an Na here and a PO4 here and a PO4 here. So the things that were connected in my reactant side have now found new products in my product side, or new partners in my product side. And I had 2 complicated things on the left and 2 complicated things on the right. So that is a double displacement. Number 8, same thing. I got lots of complicated stuff going on. I have a magnesium here and a magnesium here and a chlorine here and a chlorine here. So again, 2 complicated things turn into 2 other complicated things where things get swapped out. So that is a double displacement. Number 6 looks complicated again, but if I start looking at it, I see, oh, hey, wait a second. There's an oxygen, carbon dioxide, and a water. So it is that special type of double displacement called combustion. Number 10, I don't have 2 complicated things. I have lead all by itself over here, and then I end up with iron all by itself over there. So that's where one element kicks the other one out of the compound, and that is a single displacement. All right, number 11. I have one big complicated thing, only one reactant getting split into 2 products. That is decomposition. And number 12, I have the opposite. I have 2 reactants getting combined into just one single product. So that is synthesis. Number 12 looks big and complicated again. I got, let's see, RB there, NO3 there, NO3 there. So it looks like everything's getting swapped around again. That's double displacement. Number 14, I have a Cu all by itself here, and I have an Ag all by itself there, and then I got other complicated things. So that's where one metal kicks another metal out. That is single displacement. Number 15, I see some hydrocarbons. I see oxygen, carbon dioxide, and water. Oxygen and carbon dioxide and water is my telltale sign that I have combustion. All right, number 16, I got one thing here and one thing here, and then all together making one big thing. So 2 separate reactants making one product is synthesis. Number 17, I got some complicated stuff and an oxygen by itself, and then some complicated stuff and the chlorines are by themselves. That's a single displacement. $18 looks big and scary, so my gut says that's double displacement. Let's take a peek. I got magnesium here, iodine there, iodine there. So, yep, it looks like everything swapped places. That is a double displacement. And let's just hide those alerts real quick. All right, number 19, I have one reactant getting split up into two products. So that is decomposition. And number 20, oh, look at that, same thing. I have one reactant splitting up into two products. So that again is decomposition.